How to implement a worker pool in Go. A worker pool in Go is a pattern used to manage a set of worker goroutines that process tasks concurrently. It is useful for limiting the number of goroutines running at the same time, preventing resource exhaustion, and efficiently managing workload distribution. Here's a step-by-step explanation of how to implement a worker pool in Go. 1. Understand the key components. 1. Workers. These are goroutines that process tasks. 2. Task queue, a channel that holds incoming tasks. 3. Result queue, optional, a channel to collect the results of processed tasks. 4. Main routine, dispatches tasks to the workers and gathers results. 2. Steps to implement a worker pool. Step 1. Define the task. Decide the type of tasks the workers will handle, e.g., processing data, performing calculations. Use a function or struct to define a task. Step 2. Create the worker function. A worker is a goroutine that continuously reads from the task queue, processes tasks, and optionally sends results to a result queue. Example flow: receive a task from the task queue. Process the task. Send the result, if applicable, to the result queue. Step 3. Initialize the task and worker channels. Create buffered or unbuffered channels for tasks and results. Buffered channels help control back pressure when tasks arrive faster than workers can process. Step 4. Start workers. Launch multiple goroutines, workers, to process tasks from the task queue. Each worker reads from the task queue in a loop until the queue is closed or all tasks are processed. Step 5. Send tasks to the task queue. Use the main routine to distribute tasks into the task queue. Ensure that the task queue is closed after all tasks are sent, signaling workers to stop. Step 6. Collect results, optional. If results are needed, collect them from the result queue in the main routine. 3. Key points for implementation. Concurrency management. The size of the worker pool determines the level of concurrency. Adjust it based on system resources and workload. Channel closing. Properly close the task and result channels to avoid deadlocks. Graceful shutdown. Use mechanisms like sync.waitGroup to wait for all workers to complete processing before exiting. Use cases of worker pools. 1. Web servers, handling HTTP requests concurrently. 2. Data processing, parallelizing large computations or file operations. 3. Task queues, processing jobs from a message queue like RabbitMQ. Benefits of worker pools in Go. Efficient use of system resources. Controlled concurrency to prevent goroutine explosion. Simplified task distribution and result collection. This approach ensures scalability and reliability for concurrent workloads in